from the, here we go. I just got told the recording was in progress. Greetings from the land of the Darug and the Gundagar, where we pay respects to the traditional custodians on the land on which we meet. My name is Kevin Joseph, and with me is Hamish Clark, and we are the organizers of Science at the Local. Science at the Local is a community initiative in the Blue Mountains that is supported by Inspiring Australia, which is a Commonwealth-funded program. The focus of Science at the Local is to strengthen the bonds between local communities and scientific research. So Hamish and I coordinate a number of events that are designed about building community through science. So as we return to our new normal, I hope that you will consider joining us at an in-person event in the not too distant future. You can keep up to date as to what we have planned through Facebook, through our website, or you can even send us an email and we're happy to add you to our email list. I'll now throw you to Hamish, who will introduce our speaker for today. Thanks.
Thanks very much, Kevin. Nice to see you all again virtually. It's going to be really nice when we can be back in person, but we're thrilled that you've all tuned in and very thrilled to have our speaker today, Dr. Angela Marahaj. Angela is an Office of the Chief Scientist Science Policy Fellow and an adjunct senior lecturer at the University of New South Wales, Australia. Angela's work has a discipline and education focus. Her research interests intersect across oceanography, meteorology, and her education expertise includes online education excellence, climate change education, and science engagement for lifelong learning across all stages. Angela, like us, is passionate about science literacy and is involved in several initiatives which aim to improve the links between schools, universities, and science research. As you'll be finding out shortly, Angela is behind the Eureka-nominated Schools, Weather and Air Quality Citizen Science Project. She's also co-chair of the Science Development Team for the World Climate Research Program Academy, and is the current president of the Australian Meteorological and Oceanographic Society. So welcome, Angela. Thank you so much for joining us. And before I hand over, just for the audience, please pop all your questions in the Q&A, and then we'll get to them at the end, if that works with you, Angela.
Thanks so much, Hamish. And thank you, Kevin and Hamish and Science at the Local team for inviting me to talk about schools, weather and air quality. It's a privilege. I really wish we could have done this at a local. That would have been really nice.
Next time, next time.
But yeah, no matter. I do have a drink with me and I will drink it responsibly and slowly while I attempt to give a talk so I don't slur my words. Now, let me just share my screen so we can move along to something more interesting than looking at my face. So can everyone see that now?
Looks good.
Yep, great. Okay. First of all, I'd like to acknowledge that this project is a team project. And the lead investigator for Schools, Weather and Air Quality Citizen Science project is Associate Professor Melissa Hart. She's in the audience, so she'll be able to chip in with some responses, I'm sure, if there's a lot of discussion around various things. Melissa, our colleague Giovanni De Virgilio, who was a postdoc at the time at UNSW, and I pulled together this project, which is funded by DISA, the Department of Industry, Innovation and Science, in a citizen science grant. And there are many other people who've worked for us. I've included Giulia Ulpiani here on this slide because some of Giulia's work is being presented in these slides, but there have been many other people on the SWAQ team who have helped to get the project up and going. So I want to acknowledge them all, even though I can't mention everybody's names. Okay. Oh, I can hear thunder. So I'd just like to acknowledge the traditional custodians of the various lands on which we are working and presenting this today, and the Aboriginal and Torres Strait Islander people participating in this event. I'd like to pay my respects to elders past, present and emerging, and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of New South Wales. I'm coming to you from Ballymedegal in Darug country, which goes from Thornley down to the Parramatta River in Sydney. And if you would like to acknowledge where you are coming from, your traditional land, please feel free to do that in the chat. Thank you. Okay, so what is SWAQ? So it's Schools, Weather and Air Quality. And this is a project, as I mentioned, funded by DISA. And the idea here was that we wanted to be able to place weather and air quality sensors in schools across Sydney. Our vision was that we would have sensors in schools, students would collect and analyze research quality data, and we would be able to create science and math curriculum aligned classroom activities for the students to be able to use. And being citizen science and a government-funded project, we wanted to make the data freely available online to the public and to researchers. So I mean, I think in terms of the idea itself, that sounds probably fair enough. But we had to think about really how this worked in terms of being able to produce some good science. So the key here really was that we needed to be able to get weather and air quality data. And what we wanted to do was understand the role of urbanization on outdoor environmental quality. All right, we went for the citizen science approach because what we were trying to do was to be able to fill in gaps in the regulatory sensors. So there is a network of sensors out there. You know, for weather, we have the Bureau sensors, and then for air quality, we have weather and air quality sensors that are cited quite differently. The aim we had wasn't necessarily to just collect data everywhere, which would be fantastic to have, but we really, you know, when you are working with limited funds, you need to think about what it is, what's the science question you're trying to answer, and how that is going to add value. So the value that we were trying to add was to, in fact, try to collect data where we thought that there were perhaps gaps in the regulatory sensor network where we may be able to fill in additional information. And that would be to be able to have a better understanding of what weather variables and air quality variables look like across Sydney. And the idea of this is to be able to understand how local weather impacts local air quality, maybe get a better understanding of what local air quality looks like in across sort of suburbs, so at a suburb level, down to a street level, and to be able to investigate the impacts of extreme weather or extreme air quality events. Now, often we talk about schools because, you know, schools hold a very vulnerable population, I suppose, and it is fairly important to be looking at the impact of air quality and extreme weather events on vulnerable people. So young people come in that category. But I just want to, before I go any further, just say that I think sometimes we have to be careful when we talk about schools, because it sometimes sounds like we're saying that schools are this sort of very high risk area or a high risk place to be. And that's not necessarily what we're saying here. The reason we chose schools was because schools were a good demographic and a good community group to engage with in a citizen science project, because schools are in every single suburb. So when we tried to figure out where the gaps were in the network, we thought about how would we have our sensors hosted in a safe, secure place where the information would be useful to the people who are hosting the data and the sensors for us, where the data would be useful, and where we would be able to get meaningful information. And so schools were just an ideal location for something like that, right? And it meant that where we had gaps that we wanted to fill, if there was one school that wouldn't host it, we knew that there were many other options that we would be able to go for. So there'd be many other schools. So the motivation for doing this work really is projections for Sydney's population is that it's going to grow for about 30% in 20 years, right? So that's an increased urbanization. It's quite significant. An increased urbanization will have impacts on urban air quality and urban climatology. And what we really wanted to do was to be able to explore what was happening in these growth areas from a meteorological and an air quality perspective, because it's sometimes hard for the regulatory sensors to keep up with the rate of expansion. And we thought if we can get in there and put some sensors in, it would be fantastic to be able to see what it is that is coming out of it. So the need here was to increase monitoring sites with research quality data for across Sydney. And the want, including that need, was, well, wouldn't it be great if we could do this in a way that had community engagement and agency regarding urban meteorology and climatology? So wouldn't it be great if we could have weather and air quality data produced in a way that allowed the community to be engaged in it and also to be able to use the data for decision-making processes. So the key thing we were thinking about, in fact, before even air quality, was the urban heat island effect. So most people are, I think, relatively familiar with the concept these days, but if you're not, just to sort of do a very general description of it, air in the urban area is generally warmer than air in the surrounding countryside. And that has to do with the built environment, sort of the types of building materials and surfaces that you find more prevalent in an urban region versus a countryside or rural or semi-urban environment. So lots of land clearing, lots of dark surfaces, lots of sealed surfaces, buildings, glassware, exactly, etc. And what that does is it changes the temperature profile of the area compared to the surroundings. So if you look at surface temperature or air temperature, if you look at the daily variability or the seasonal variability or the spatial variability, so the geographic variability, you can see that there is this urban signature. And the urban signature usually means that you have a warmer temperatures. So for example, if you look at this sort of highly idealized schematic here, this circle with the city at the center, and if you were to measure the temperature across that, you would find that the more built part of the urban environmental landscape has much higher temperatures. And the crucial part of that is that it's in fact, when you're expecting temperatures to cool down, going to the evening and overnight, that you tend to still see a warmer temperature in the urban landscape. And that's known as the urban heat island. And there are people who do fantastic work in this sort of thing. Melissa Hart is here and she'll be able to talk about this if you want to know more, where they look at the surface temperature of various materials to see how they interact with radiation and what their thermal effect is. So here, for example, is a picture that Melissa has provided. And you can see two buildings here. This is in Portland, Oregon. And you have the engineering building. This is the university. On the right-hand side, the roof space here has a high reflective surface. So as we mentioned albedo down there. Albedo is the reflectivity of solar radiation. And then you have this much bigger building in the foreground with a dark surface on the roof. And if you look at the thermal, if you look at it through a thermal camera, you can see that you have much warmer surfaces in that dark roof on the left-hand side rather than its neighbor, right? And so it just gives you an example of how the types of materials that you have in a landscape can have a big impact on the thermal environment. Okay, so we were keen on looking at the urban heat island effect in Sydney. And so what that means is it means that you have to put your sensors in built environment spaces, right? So you probably have driven past maybe Observatory Hill or driven through the countryside and occasionally seen one of these things, which is on the left-hand side of my slide, in a sort of a fenced-off space in a well-cut lawn, big grassy surface with meteorological sensors, a little white box called the Stevenson screen holding temperature, relative humidity, a type of instruments, and then perhaps some other instruments that might be looking at things like cloud height, radiation, etc. So that's the kind of thing that the Bureau has, and they all need to be consistent so that the data that's collected from them makes sense across a vast geographical space, right? That's not what we're looking for. We're looking to put sensors in spaces where you have lots of built surfaces. So you've got street canyons, you've got playgrounds, you've got courtyards, you've got concrete, etc. So the Bureau sites that are used for the weather observations and forecasting meet a certain World Meteorological Organization standard, so that they can be all consistent across the board. But there is a different guidance for observations at urban sites, and that's what we've tried to follow. And so we've got sensors, and our sensors come from Vaisala, which is a Finnish company that does a lot of weather sensors and some air quality sensors. And so we've put instruments that measure weather variables. So we've got pressure, temperature, relative humidity, rainfall, and wind speed and direction, and air quality sensor that does NO2, SO2, carbon monoxide, ozone, particulate matter 2.5 and 10 microns, and also has some weather variables as well. And so we're taking these sensors and we're putting them in places where we want to know what people are experiencing. And so these sensors are also actually fairly like they're closer to the ground, right? They're about 2 meters height, so you could actually walk up and touch one. We don't recommend doing it, but you can. And that's because we want to know what the thermal environment is, what the wind speeds are, what the air quality is in the space that people are occupying at that time. So those sensors we've put in schools. Now, we wanted to make sure that we had zero cost to the schools that were involved in our program. And that meant that we provided everything, and we did not wish to have, I guess, complexities like having to access their power source, etc. And so we've used solar panels for our sensors. This is very common, of course. Most of the time, if you're looking at any sensors out on a building site or maybe by the side of a road, you'll see that they have solar panels attached to them. Now, the thing with solar panels is you need to be able to actually access solar radiation for them to work. So whilst, of course, we wanted to be in the built environment, we also needed to choose locations where a solar panel would effectively work to provide sufficient power for the instruments to work, tick over all the time and charge the battery and keep ticking along. And so you'll see, here are some examples of our instruments that are sited across schools. So they still tend to be generally in a sort of a green space, but they are still close to buildings. They might have trees around them, so they might, occasionally have some shade. There's concrete very close by. They might be near play surfaces, etc. So there's a lot more heterogeneity, I suppose, with our sites. And one of the key things with collecting good data from such heterogeneous sites, going along with that sort of urban WMO guidelines, is to collect good metadata. So we had to collect a lot of information about where these are sited and what the what the actual surface area looks like and what's close to it. Okay, so those are our sensors. We've put them in locations where we could see that there was a gap, in the sense that there was a big distance between where other regulatory sensors were. So we did a gap analysis with some GIS and a gap analysis, and we identified areas where we thought, okay, we do need a few sensors in these areas because we can't really see a regulatory sensor that's quite close enough. Maybe there's one coming, maybe it'll be a while till it's there. And then we went and we approached schools in those particular areas and asked if they would like to take part in the program. And that's how we ended up with certain schools. But in order to, I guess, deliver that data back, we realized that weather and air quality and data itself as a citizen science project can be quite difficult to engage with, right? I mean, I guess everyone who's here is probably super interested in the weather and air quality, so that's fantastic. But it's not the kind of engaging project that you might get if you're, I guess, identifying plants in your garden for pollination, if you're looking at perhaps recyclable materials, or you're taking photographs of bush turkeys or something like that, where you're out in the environment and you're actually collecting the data yourself. Our project isn't like that, right? So our project has some pretty nice sensors. These are mid-range price-wise sensors. They cost quite a bit of money. They're not your super low cost sensors. They're certainly not your very, very expensive regulatory quality sensors. And what we've done is we've tried to get people to engage with helping us to collect the data about the environment around us. But how do we give this back in a way that'll be, I don't know, fun, engaging, people would look at it? So in order to do that, from the get-go, we thought, okay, we'll need to co-design how we deliver this information back to the schools and to the public. And in order to do that, we consulted with the schools. And what we did, in fact, was we consulted with high school students. So our sensors are in primary schools, And the reason we chose primary schools was because there are many of those per suburb, which gave us the option of being able to, go to a number of possible hosts to be able to get the sensor into that particular suburb. But in terms of, I guess, being able to have a good level discussion about the importance of the data and how to visualize it, etc., and being able to, I guess, access students, we used high school students, and we're hoping that they will use the data at a higher level than the primary school community would. And so we had workshops. We did some user-centered design workshops. We had a whole bunch of high school students come in through a few different workshops, and we asked them all sorts of stuff. We asked them what they knew about air quality, whether they're interested in it, where would you look it up. We were quite lucky in a way that when we first started running these workshops, it happened around a dust storm event. So we were able to ask the students about that, were they aware of the dust storm event? Did they know anyone who was affected by it? And so we were able to get a bit of an understanding of what it was that students knew about weather and air quality, what they cared about, and also how they might access that information. So, we asked them, what do you do? What devices do you use? Where do you look up weather? What do you care about when it comes to weather? Some of the things they told us, for example, was Mum tells us about the weather. Many of them just look up the weather on whatever device they use. So, they turn on their laptop and there's a notification or an icon as part of whatever, so internet browser, for example, that they're using that tells them a little bit about the weather. Many of them cared about temperature and rain because it impacted what they had to wear and perhaps what activities they were a part of. And what they seemed to really care about was, well, I'd like to know what today was like compared to yesterday, because I know how I felt yesterday. I know what I wore yesterday. So I'd really like to know whether today is, like hotter or colder than yesterday, or wetter or drier than yesterday. So that was a really interesting insight. With air quality, we found that many students were not particularly aware of air quality issues unless they had traveled a lot overseas or were perhaps migrants who had lived overseas previously, or either had asthma or some sort of respiratory condition in their family or a close friend. So we asked the students to also help us to consider how we would visualize this information. So if you could have your own website, and let's not worry about how much money it costs to build anything, just tell us, how would you like to see this? And this was an air quality example. This was what the students came up with, and they said, well, it'd be really great if there was, like, I guess it's a heat map. They didn't call it a heat map, but there's like a heat map of air quality. And they drew this up, and this is meant to be Sydney. And they said, well, you could have a little shading to show us what the air quality is like in different places. And it'd be really good if you could have some icons. And so they came up, one group came up with this lungs, so you had your good air quality, and then when the air quality was poor, your lungs kind of got like darker and shaded. Some came up with this idea of having your little emoticon, but you gave your emoticon a face mask. This was before COVID, right? So it's kind of interesting that the face mask was there. I suspect these may have had students in that group who have had overseas travel or living experience, because masks are quite common in other parts of the world. So this was their idea of how to visualize air quality. When it came to weather, they gave us a whole host of other types of things. They said it'd be great to have little icons showing us, what was happening, and the chance of the rain, and let's be able to scroll down and look at more information if we want to. Really, really nice ideas. And of course, we couldn't do everything that they had asked for, and they had some really interesting and creative ideas. But we pulled that together, and we kind of distilled it to figure out what was the key elements of what the students seemed to be interested in or attracted to or thought was engaging. And we worked with some fantastic people, a company called Small Multiples, who helped to develop our website and our data portal, and a few other people who helped us to pull it together. And we were able to come up with a website, which we hope is engaging and interesting to school students as well as the broader public. And so it's got, I guess, a lot of colorful elements to it. It's got the map. You can go to various schools and you can find the school on the Google map and you can look up the school. And we've got icons that I guess are sort of color coded and show you what the temperature, the humidity, the precipitation, the winds are like for various sites, and air quality as well. We didn't go with the heat map idea, and part of it is because we want to make it really clear that these are point source data and we are not interpolating across the entire suburb or the metropolitan area, right? So we don't want people to be, I guess, we don't want to create misconceptions that there is information in our network about places where we don't have a sensor. But feel free to have a look at the website, www.swaq.org.au, to see what it was that we ended up developing, thanks to the kids. So from that page, you can go into each of the schools. The schools have a nice little dashboard and you can look at some select information. We haven't put everything up there because we thought we would provide the things that were most relevant and because we didn't want to just bombard the page with lots of information. And one of the things we were told by Small Multiples and the user-centered design consultants we had, Tobias, was don't put everything in. So you can see, for example, that you will have information about some general weather, and we've gone with the whole, what is it like compared to yesterday, which is what the students really wanted. And then we have information on select air quality information as well. So we've got PM 2.5, PM 10, ozone, and NO2. And because we're still trying to do science and we want the students to get used to looking at some scientific data, and we know that there will be people, I guess, in the general public who may use the website and wish to look at some scientific graphs, we also have some line graphs. So you can look at the 24-hour or the 7-day average on that website, and that'll be a line graph. And it's compared to a 24-hour rolling or regulatory standards to give a sense of what it is that it's showing. Now, one of the challenges of having a live data portal on a live website is that not everything works all the time. So if you turn up on the website and you go to your favorite school or your local area and the sensor is not up and running at that time, my apologies. We're constantly having to look at the website, picking up on anything that might be happening. Sometimes the issue might be that there hasn't been sufficient power, and so a little bit of data has not been collected before the battery is back up and running. Sometimes the issue, most of the time actually, the issue is we're collecting the data, but it's just not transferring over to the data portal. But we do collect everything. And in fact, the full data set is available from the Turn website, which is an open data site, and you can find the information there. You don't have to remember this right now. If you go to our SWAQ website, there are links to it from there. Okay, so we had buy-in from teachers and schools, and we helped to create some lesson plans that align with the Australian National Curriculum as well as the New South Wales syllabus. And so we've focused on primary first because we thought primary was the most, they are the people who are hosting our sites. And so we wanted to make sure that we delivered them lesson plans first, but we also have lesson plans for high school students as well. And we've got a few more coming through. And so the idea is that you can use the SWAQ data, right? If you're a host school, you can use your own data. If you're a non-host school, you can still use these lesson plans. You can collect the data from the website and you can do the same sorts of exercises. And you can look at things like temperature, rainfall, air quality, and they're linked to the syllabus so that the teachers can see the relevance of it to their programming and justify spending time doing these. And part of the project, we did a lot of engagement. So we took part in lots of outreach activities. We had students who attended UNSW as part of outreach programs that we ran little exercises with. And we're also collaborating with some of our other scientific colleagues who are working with low-cost air sensors, air quality sensors, or collecting sort of greenhouse gas samples to see if we can, collaborate and have sort of a more holistic, I guess, data collection and relevance of the project. Okay, so thinking about some of the results that we've had, and I'll finish up soon. I talked about urban heat island. So I've got just a few examples of the types of data that we've collected and showing the relevance to it, to the scientific outcomes that we were interested in. Here we've got some temperature variability data from 3 SWAQ sites. So we've got UNSW in yellow, we've got Glenorrhea, which is up north, if you can see up here on the map. So more of a bush area. And then we have Ludnam, which is out here in the west. Now, UNSW is the most built of these sites, it's the most urbanized site. Ludnam is out in its southwest. It's certainly got some built spaces, but it also has lots of, it's more sort of semi-urban, I guess. There's lots of green spaces as well. And then Glenorrhea, as I said, is a bush site. And if you look at this data, you will see that there is a heat island signature in overnight temperatures. So if you can see the UNSW line, you'll see that it doesn't go as far down, it doesn't cool down as much, and it also drops down a lot slower than the other sites. So we're able to look at the difference between these sorts of sites and think about how we might quantify the urban heat island effect in these various sites. Here we have an example of air quality information. This is the temporal variability of PM2.5 in November 2019. So this is around the time of the Black Summer bushfires, right? And these are 6 SWAQ sites. We've got Brookvale, Glenorrhea, Kurnell, Leppington, Ludnam, and UNSW. And our sensors were able to identify several significant peaks across the network, and you can spot them over here. The dashed line is the regulatory guideline. And these were often between 3 and 8 hours of these peaks. Now, they were not always as consistent as it looks in this particular graph. Sometimes it was consistently across the network for some of the events, but sometimes there was quite a bit of geographic variability. So it's not to say that when there is an event happening in Sydney, it is seen everywhere or has an impact everywhere. Going on with air pollution. So these lovely little pictures here. And I'd like to give a shout out to Giovanni De Virgilio. He might be here in this talk. He did the bulk of this analysis, and we have a paper that you can look at, which is available open access, which has this data in it. So here is an example of looking at winds and air quality for the Glenorrhea site. So this is again during the Black Summer period in this is from September through to May, so September 2019 through to May 2020. So winds are obviously important to understand meteorological drivers of air quality. And so what we're looking at here are wind direction and the air quality concentrations of PM2.5 associated with a particular wind direction. And so you can see, for example, here in November, 2019, there's a range of wind directions which all seem to be associated with poor air quality. But then if you look at December and January, you can see that it really is more around northwesterly and southeasterly winds that primarily affected the air quality levels during that time. So again, it's not necessarily consistent. It does really depend on the climatology. And finally, this is an example of the work where we're using that data to try to identify the source of the air quality event from the meteorological variables and looking at the associated synoptic patterns. So this is for the 26th of November. And in that time, I know this is a very busy slide, so apologies for that. This bottom line here is the PM2.5. Right, so that's our air quality, and we can see that there were 2 peaks of 2.5. And if we looked at it with the synoptics, what it looks like is that there was a cold front that passed through. And so what that did was it shifted the winds around to the northwest. And then as the front passed through, it shifted it back to the southeast. And so looking at the meteorological variables, the synoptic maps, and then Giovanni did some back trajectory modeling for this. And it looks like in terms of the impact of the air quality at Glenorrhea, it was the fires to the northwest of Glenorrhea, which was impacting the early morning peak that was seen. And it was the fires to the southwest. So that's that one over here. The yellow dashed line is the morning one. And then it was the fires to the southwest of the area that created the afternoon peak that was with the adverse air quality that was noticed at Glenorrhea. So this is the paper. And again, you can just go to our website to get access to it because it's a citizen science project. We found some funding to be able to make the paper open access so that everyone can have a look at it. There is a plain language summary that comes with the paper as well to help people to understand what it is that it might be trying to say. Okay, so some key findings. Heat island impacts are detectable in the SWAQ data. That's some ongoing work. The Black Summer fires frequently had Sydney-wide air quality impacts, but the onset, the duration, the severity, that was all quite complex, and there's quite a bit of spatial temporal variability in that information, which really shows that it's worth having these low-cost sensors across, I guess, Sydney, but in fact anywhere. And they do provide value. And we think that the key to it really is that if they can complement your regulatory network, then they value add to the regulatory network, and they can help us to get some useful information, which may help inform state government as to where perhaps they may be looking to put their, where would be best to put their next sensors when they have them available. And some new work that I haven't had a chance to talk about, but it's ongoing, perhaps another time, would be the impact of COVID lockdowns on local air quality. So we did notice that there were some places where, the diurnal peaks that we saw from traffic had flattened out. So that's something we're looking at the moment. Okay, thank you very much. I'll stop there.
Thanks so much,
Thanks,
Angela.
Angela.
Oh, you go, Kevin.
No, I was just saying thank you. Thanks for that.
That was great.
Yeah.
We do have a few questions, so we might as well open it up to them in a Q&A. If you haven't asked a question yet, please just type it into the Q&A and we'll try and get to it. So the first one is from Kate, who says, how did you address with students the scientific consensus that there's no level of PM 2.5 that doesn't harm health, i.e. there's no safe level of small particulate air pollution?
Thanks, Kate. Yeah, you know what, those sorts of issues are definitely difficult to discuss and to communicate. We make it very clear in our papers that there is no level of 2.5 that is considered to be safe, but we haven't designed educational material around the health impacts of air quality. And part of it is, so it's twofold. So one is that the sensors that we're using are mid-level sensors. They are not the best possible sensors that one can use. So those would be the regulatory standard sensors. And we don't necessarily want to create, I guess, panic and ill-informed. We don't want to give ill-informed information. So we haven't focused too much on, like if this is the air quality you're seeing in your school, then there is a massive health problem at your school. We don't want to do that. We want to have an informed and scientific conversation around it. And I think there are some significant policy implications. So what we're hoping for is that the schools are able to look at the data and make some decisions on the day. So for example, if you have a bushfire event or a hazard reduction burn, or for some reason you have poor air quality, so it could be, a dust storm event, for example, doesn't have to have anything to do with bushfires, that the principal can have a quick look at the data and say, okay, it's lunchtime or recess time, should the kids go out? Or should we keep them in? Or if there's a heat wave, what are the temperatures looking like? Should they go out or should they go in? The advice that they will make the decision on is not advice that we give them. It's the advice that they will get from the state government and from the health orders. And we provide links to those on the website.
Terrific. Well, that feeds right into the next one. I think you might have answered it even, which was Alana asking whether you offer a school's advice about what to do if measurements indicate increased risk. So you're suggesting that they potentially can use it to help make a decision, but you're not specifically advising. There's other sources of advice for that. Is that right?
Yes, absolutely. We are not health experts. We would not presume to be the people who give the advice on the health. And we also make it really clear that the data that you look at on the website is real data coming in, which means that it's, there's a minimal quality control to the data. So I think anytime when you look at data, you need to think about the quality and you have to scrutinize and you have to look for, I guess, corroboration. So we would not suggest that people just look at that particular site, we would say, to have a look around and see what the advice is from the, go to the DPI site, look at the EPA site and look at what the advice is there. But then you can also look at your local and think about whether, perhaps you should stay indoors or perhaps you should change your activities for that particular time period.
Thanks, Angela. Alana was also wondering whether SWAQ would consider collaborating with other citizen scientists or projects such as to create a combined map, for example, Purple Air, who use low-cost sensors on a public map and have been used by the Armidale Council.
We would absolutely love to collaborate with other citizen science projects. As I said, our data is available freely, so we're more than happy to also make our data available on I guess, there are a number of portals where you collect citizen science data. We're certainly open to that as well. Yes, absolutely. We would be happy to collaborate.
Can I just give a quick shout out to Springwood High PNC, and there are some great students who did some wonderful work two years ago for our local community. I think some maybe even hear from people from the PNC, hopefully. But yeah, that was a great question, Alana. But I just want to give a shout out to students, because I love when students doing things and supported by the PNC, and they can hear your talk and say, wow, okay, there's somewhere for me to go with this. So just a quick shout out to Springwood High. I'll go to the next question then. Matt said, how is the current air quality data being used at schools that have monitors? For example, if measures are above the state limits, are alarms, any actions taken, such as students moving inside? Which earlier question.
That is something we were really hoping to be able to get moving along in terms of decision making and agency. We wanted to see how useful this would be or whether it would be used in practice. Unfortunately, the past 2 years with COVID and restrictions and lockdowns has meant that we haven't been able to do this. We've got, I think, about 12 sensors out there. We've got a few more we want to put up, and we haven't been able to access schools, for example. So we haven't really been able to engage with the schools to get, like, for example, through the summer season, you go, okay, that's your, well, we've got extreme weather already now, but summer season would be when you think about heat waves and bushfires, and then start engaging with the school and saying, okay, this is the time to start looking at the data, and then tell us how that's working for you. Unfortunately, that hasn't happened. So we would hope that that can maybe happen from next year. That would be great. My understanding is that some of the schools are looking at the data more than others. And my understanding is that it's being used more for thinking about program and lesson planning than it is for actual decision making at the moment.
Thanks. Yeah, Matthew had another question. So he's involved with the PNC for Roselle Public School, and they've just set up an air quality station and looking for best use of the results, and was wondering how parents have been engaged and whether you have any advice on that.
Hi, thanks, Matthew. I think you sent an email as well, so we can send you a reply back later as well. We haven't engaged with the parents. So I guess one of the things that we needed to think about was exactly what this particular project was going to do. And because this particular project essentially puts monitors into schools and collects that data, we provided information to the schools to provide to the parents, and we certainly offered to come along and have a chat with the parents and give some presentations if they would like us to. So we didn't start off by engaging with the parents. We engaged with the school and we engaged with students, as I said, for the co-design of it. And then again, COVID has got in the way. We had expected to be turning up to a number of schools by now with our paper and sort of, simplifying the results to be able to present, to come along to a PNC and do a little presentation. And again, COVID has unfortunately got in the way, and we haven't been able to access schools. But yeah, I should hope that we would be able to do that a little bit.
Thanks. Carl's got a question. He's asking, do you recommend the use of misting fans for schools, as they offer both cooling and dust suppression? Are you able to answer that?
Thanks, Carl. Unfortunately, I don't have an informed opinion on that. I will say, though, I think it really depends on your local conditions. So the type of project that we created, where you put 1 or 2 sensors in a school, is going to give you some information about the local environment and going to give you some information about the local school, but it doesn't identify what the source of the emissions are, and it doesn't identify what sort of the micro scale variability of air quality, for example, if it's air quality that you're concerned about for a school as well. I think there's a bit of a danger in thinking that having 1 or 2 sensors in a school is going to help you to fix problems at that school. It's a very different experimental design if you wish to look at a specific area and think about how to mitigate issues in that particular space. It doesn't even have to be a school. So I think in terms of misting, it will probably really depend on what the emission sources are and what the variability is of the air quality in the space.
Thank you.
Thank you.
I'm going to jump in and ask a question if that's okay. If anyone has any more questions, please pop them in because we'll be wrapping up in a minute. So there's still time. But I'm just curious what kind of response there's been amongst scientists to partly the project, but maybe citizen science more broadly. Do you find people are generally kind of supportive and excited, or some kind of hesitant or skeptical, or how much control are they willing to cede to citizens? Any thoughts on that?
So I think one of the things that I found really lovely about the Citizen Science Project was how much people just get really excited about it. Scientists were excited about it. Grown-ups are excited about it. Kids tend to be a little bit more, sort of too cool to be excited. It's hard to get kids engaged. And that was really nice. I think citizen science has this really lovely vibe to it. And I think most people are quite, we have a fairly romantic view of what citizen science means. I must say, I personally had a lot of reservations about citizen science, and my reservations were not so much around engagement. I think it's fantastic that we have the engagement and that we're helping, get everyone collecting data. My concerns are around, are we creating some misconceptions about how science is done? Because we only give citizens a small glimpse at one part of the process, right? Which may be the data collection. They may not see the quality control aspect. They may not see the corroboration aspect. They may not see the statistical significance aspect. They may not see the peer review process or the consensus of many, many papers having to show the same thing before you can say, this is in fact what we think is happening. So I think there are some dangers, like a little bit of knowledge can be dangerous. And I think there are some dangers with that we, as scientists who are engaged in citizen science, we should be thinking about, so that we are delivering information about the scientific process as well, and not just, I guess, maybe using citizens as cheap labor.
Great answer. Thanks, Angela. That's really interesting. Look, if there aren't any more questions, we'll wrap it up there. Before we go, though, we wanted to let you know we've got another event coming up on the 31st of October. Oh, another question has just come in. Just quickly mention, yeah, so we've got an event on the 31st on bioremediation. We'll share details of that in a moment and through other channels. And I will thank you, but then I'll also mention this other question has just come in. So thanks so much, Angela. Awesome talk. Thank you for your time. Kate wants to know, air quality is associated with COVID vulnerability. Has the project reflected on this for outdoor as well as indoor air?
Thanks, Kate. We haven't looked at that yet. I think, well, I guess we probably won't be able to look at that in any sort of sufficient extent. We are not collecting indoor air quality information at the moment. But again, I guess I might hark back to what I was saying before in terms of the misting as well, in that I think in order to do that for a specific location. So, I mean, in terms of, there's like quite a few papers out there now looking at air quality, weather variables and COVID, absolutely, right? So well worth looking at those, but I think there'll probably be a lot more work done before there's really strong consensus on how that might translate to policy or practice or standards. But in terms of looking at a specific location, whether it be a school or a building or a home, etc., it's a very different experimental design to putting 1 or 2 sensors, which tells you a little bit about, you know, an area. You would normally probably want to put many sensors across many rooms and many spaces to get a really good understanding of what the variability is, because ventilation is really important. You know, orientation might be important, all sorts of stuff. So it's a completely different experimental design. We did think about doing that at the start, and we realized that what you'd have to do would be we'd have to put all our sensors in one place, basically. And that's not what we got the grant for. We know that the project that we had presented was to fill gaps in the regulatory network and try to understand what was happening in between those regulatory sensors. Yeah, but I will also say, before we finish up, that there are some really, really interesting and cheap ideas out there already that can be, like, strategies that can be used. So if you do have concerns about air quality, you know, either in a school or in a space, sometimes a lot of things are out of our control. You know, many schools are like near arterial roads. I'll give you one great example. So somebody told me about a school where the parents would come to pick up the kids in the afternoon, and everybody would stay in their cars, but they'd leave the cars running, right? So the cars would be idling. And so that's clearly going to create a fairly short time of poor air quality, but it certainly is going to create a poor air quality episode exactly the time the kids are coming out of the school to get into the cars. Do you know what they did? They put up a little street library. And the parents turned off the cars and walked over to the street library to see what books were in there and to swap books. So sometimes it's just really simple strategies that you can use, right? And we need to be careful when we come up with policy ideas that we don't create new problems when we're trying to solve old ones. So it would be very easy to look at poor air quality and say, oh my goodness, we should all get into cars and drive to school or to work, rather than walk or cycle when we're, you know, going to be exposed to air quality. If we do that, we're going to create a whole new set of problems, unless we'll go out and buy Teslas, right? So we have to think about the problem in a much broader context in terms of solutions, and maybe think of some really clever ones.
Thank you. Yeah, that's an excellent note on which to wrap up,
Yes.
Angela. So yeah, thanks again so much for your time and your talk. We're recording it, so if anyone wants to check it out afterwards, we'll upload it to our YouTube channel. And yes, as we mentioned, the next talk coming up at the end of this month from Mike Mainfield at UNSW on bioremediation. So we'd love to see you there. And yeah, thanks to everyone for joining us, and enjoy the rest of your weekend. See you next time.
See you next time. Thanks, Angela.